So we've covered unbuffered channels in the past, where whenever we have to perform a send operation or a receive operation, we need a corresponding receiver or sender. So what this means is that we can encounter deadlock, or we can encounter situations where a send operation has to have a corresponding receive. But in certain cases, for example, asynchronous use cases, where we have asynchronous message passing between Goroutines, we want to bypass this blocking behavior of unbuffered channels. So how do we do this? Well, the mechanism that Go has provided us is something called a buffered channel. And this allows the Go routine to send multiple messages without being blocked by an immediate receiver. And this is very useful in certain scenarios when you want to decouple the speed of the producer or the sender and the consumer or receiver. So let's take a look at this code snippet and understand how buffered channels work. The syntax is very similar to an unbuffered channel. We make a channel of string and buffer it with 3 items. This means that 3 sends can be sent into this channel without immediate receivers for these 3 send operations. This is basically like a quota. So we spin up a Go routine called send data, and it will send 3 messages into this channel that we have instantiated here. After that, we want to close the channel to avoid deadlocks. But how does closing the channel actually avoid deadlocks? The answer is on line 17 and line 18, where we receive data from the channel. So for message in range of this channel, we want to print the message as it's pushed into the channel. So this Go routine will push message 1, message 2, and message 3 into the channel. And as this for range loop runs, it's going to print the channel messages one by one in order, message 1, message 2, message 3. But it will continue processing items in the channel and essentially hang indefinitely, resulting in a deadlock if we do not close the channel. This closed channel indicates to this for loop that there are no more entries that are going to be inserted into the channel, meaning that this for loop can complete and then the main function can exit. So let's say we add a fmt.println finished here, and we run. So we see message 1, message 2, message 3, and then finished. Let's say we remove this close channel operation. We're simulating a deadlock here. When I run this code, it says, fatal error, all Go routines are asleep, deadlock. And you can see that we're actually able to detect the deadlock situation during runtime.